Hello, this is a screencast to introduce the final media computation project for Programming 1. And we're going to call this media computation. And that term comes from the fact that we're using a type of media, so like a song or an image, for example, and doing some computation on it, right, to manipulate it. And this can be done with songs, this can be done with pictures and videos, it can be done with all sorts of different things. In our case, we're going to use images, and we're going to manipulate those images to apply photo filter effects to them. Ultimately, what we're going for in this lab, if you scroll down, you can see we're going to take an image or a selfie that you have and apply this Shepherd Fairy filtering effect of a 4-color palette to recolor your image to look like this. So that's where we're headed. So the reason we're going to do this is going to put the programming concepts and the computer science concepts we've learned over the course of the semester into the context of a project, right? In this project, like I said, we'll create our own images and image filters. To do this, we have to understand a little bit about what a pixel is. So whether you are aware or not, digital images, like you might see on your computer screen, or you might take with your phone or digital camera, they're broken up into bits called pixels. And pixels, right, short for picture elements, are boxes of color, right, that make up a picture, that form a picture. And these little boxes of color are organized in a grid structure, right? Think of it like a two-dimensional matrix of pixels. And we can think of this as like a coordinate system of in the x direction and in the y direction, you've got all these pixels. So like the 0, 0 pixel would be the top left pixel. Right, so the horizontal pixels move in the x direction, and vertical pixels move in the y direction. And we can think of it that way. To see this a little bit, I've got a photo here. And if I zoom in on any photo that uses pixels, if you go in close enough, you're going to start to see these pixels, right? So in this case, if I zoom out really far from this image, it's hard to see the pixels, but the closer and closer I get, right, I can start to eventually see these pixels. And you can see how they're arranged in this grid format, right? So each row could correspond to a y value, and each column could correspond to an x value if you wanted to map it to a coordinate system. Right? So when you're choosing your photos for this project, one thing to consider is cameras can take really high quality images these days, and if you have a super high quality image with tons and tons of pixels, your programs are going to have to access each one of those pixels. So if you have a super high quality image, it might take a long time for your program to run. It could potentially still work, but you may want to think about using a photo that's not ultra high quality. It's just a photo that's, this would be a decent sized photo to work with, right? You can easily zoom in and see the pixels. Okay, so with that said then, as you can see, pixels are small. Your Chromebook, in fact, has millions of them, right, to render images in super high quality. And that's good, we want that. But it does kind of make the pixel part of it hard to see. And especially to see that each pixel actually is one particular color. And the way each color is achieved for a pixel is using an additive color scheme of red, green, and blue. So each pixel is a certain amount of red, a certain amount of green, and a certain amount of blue added together, often referred to as RGB, to achieve the color we want. You can see a little visual here of how that works. And each particular red, green, blue value gets assigned a range from 0 to 255. And depending on how intense the color is, 255 would be the most intense, 0 would be the least intense. That'll determine what the color ultimately is. Okay. We can see this if we look at this HTML color picker. You can click around here and you can find different colors you might want to use. Like for, let's say you want to use like a husky blue color, dark blue. Let's choose this one. You can see this website allows you to view the RGB values associated with particular colors. So for this color, there's 0 red represented, there's 45 green represented, and there's 179 blue represented to achieve this color. Now colors can be represented other ways, through text strings, through hexadecimal values and other ways. But for this lab, we're particularly focused on RGB. Okay. All right, so now this might be a little bit different than you're used to. You might look at this chart and say, wait, red and green make yellow, right? That's not maybe what we're used to. That's not quite like art class, right? It's a little bit different than art class, right? This is additive color rather than subtractive color. So you're going to be mixing red and green to make yellow, right? Rather than blue and green. Right? If you're interested in this phenomenon, how this works, one way to think about it is think about like a prism. If you've ever seen a prism that breaks light up, like white light, up into the many different colors of the rainbow. That's one way you can kind of experience this. Like the white light you see, all the colors combined is white, right? But then if you break it out, you can see all the various colors of the rainbow. I link you here to a little DIY project if you're interested in trying to explore this further. Right, so we're going to use this concept of pixels and RGB color values to manipulate our photos, sort of like you would do in Photoshop, sort of like they do in Instagram or Snapchat filters. And what we're going to do is we're going to access each pixel, right, and recolor it, change it to a different color. So the example, like I said, is going to be the Shepard Fairey effect. Right? Shepard Fairey is a person. It's a guy who came up with this original kind of iconic Obama hope poster from the 2008 presidential campaign. And he popularized this 4-color photo filter effect. And then you can see this on all sorts of examples now. Right? If you Google Shepard Fairey, you'll see all sorts of examples of the same type of effect. So in order to do this, what do we have to do? Well, ultimately we have to group pixels by intensity. So really dark pixels we're going to group together, and we're going to recolor the darkest color in our palette, right? This dark blue color you see in the suit, for example. Right? And the lightest colors, like the ones that might be on the white collar of the shirt, right? Those ones are going to be grouped together as well, but those will be recolored the lightest color in our palette. Right? In this case, this white color. Right? And then colors that land in that in-between range might be colored this lighter blue or potentially the red. Right? And that's how we will do this. And the lab will step you through some particular techniques to do that.